has about 178.2 centimeters. Or about 14, depends what we measure. This is Mars, a Roman god of war and agriculture, as it's displayed in the Yorkshire Museum. And yes, this Mars has 178.2 centimeters. This is also Mars. It has 677,900,000 centimeters. Or better to say, it has 6,779 kilometers in diameter. To us humans, and probably life as we know it altogether, this is a hostile world. And there are a couple of good reasons for that. High radiation, reduced air pressure, and atmosphere with only 0.16% oxygen. For comparison, on Earth, we have atmosphere with 20.93% oxygen. Another problem with life on Mars is liquid water. We now know that water in form of ice exists on Mars, and liquid water probably existed in the past. However, pure liquid water cannot exist on most of Martian surface. And where it does exist, it does not exist for a long time. So, if there is no liquid water on Mars, there is no sea. And if there is no sea, how do we measure altitude? I'm Maciej and welcome to Buffer Zone. Here on Earth, we use the mean sea level to define at what altitude we are or how high an object is. For example, Mount Everest has 8,848 meters above the sea. By the way, since we are talking about Mount Everest, I have a little riddle for you. What is the second tallest mountain on Earth counted from the base to the top? Is it A. Everest, B. K2, is it C. Haleakala, or is it D. Mauna Loa? Stay tuned and the answer will come later. However, what is the mean level of the sea? We could measure the variation of sea level at some location over a period of time and then calculate the mean level, right? Well, it's not that simple. Earth is not a perfect ball, it's an ellipsoid. And therefore, defining what is the mean level of the sea is a little bit more complex. Plus, the gravitational force is different depending what's beneath you. So, if it's a continent, the gravitational force might be higher than on the sea. If you're interested to learn more about this topic, then check the linked video from Minute Physics.
That it's 42 kilometers farther across at the equator than from pole to pole.
Alright, but assuming we know the mean level of the sea, how do we know that Everest is 8,848 meters above it? How was it measured? To find out, let's go into the mountains. And remember, safety first, it's a wild world out there. In the 19th century, a team led by Andrew Worth undertook the task of measuring the height of Mount Everest for the first time in history. It took them nearly 100 years, many measurements and calculations. Due to the political situation in the region at that time, they could not approach the mountain and they had to take the measurements from as far as 100 kilometers away. Once done, they were off only by 8 meters, which is astonishing. The main problem the survivors had to deal with was bending of the light, which travels through different densities of air over large distances, creating a mirage of an actual picture. How did people measure mountains like this when they had no GPS and no altimeter? Now, this is actually easy. All we have to do to measure how high this mountain is having one information: how high we are above the sea level, and make two measurements, actually three measurements. We have to take two angles and the length between 2 points from which we take these two angles. Let's quickly do it. So I have an application here which tells me at what angle I am looking at. Right now I have to just point it in the direction of the mountain, and I will try to look into this point there by having a straight line through the phone to it. Then I have to just stop, and I have a reading of 33.8. Done. And here we have 35.3 degrees. This is my situation. And what I want to know is h, how high the mountain is here. And in order to do that, I took the measurements earlier, so I know that we have an angle A here that has 33.8 degrees and an angle C here which has 35.3 degrees. Now, thanks to having GPS coordinates of these 2 points, I was able to calculate how distant they are from each other, and it appeared to be 39 meters, B. And don't worry about that, I just made a little mistake over here. Now, one more thing that I could take out of the GPS coordinates is the altitude above the sea level at which I was taking the measurements. And according to the map, it is 1,448 meters. Now, having all that information is enough to calculate h. And we can do it by using these two equations here, which probably are known from high school. Now, we can see from this equation that we can calculate h. However, we also have here a, which we do not know. A is here. So first, we have to calculate a. In order to do that, we can use this equation over here. We know our a angle, so we can calculate sinus of a, but we don't know b angle here. So I already know it, but let me show you how I got to it. So we know that on a straight line, these two angles here, this and this, give together 180 degrees. So if I subtract from 180 the C angle here, then I will get the degrees of this angle. And then we know also that in a triangle, all of the angles together give 180 degrees. So if I know these two angles, then I can easily calculate by subtracting from 180 what is the value of this one. And it appears to be 1.5 degrees. Now, having all this information already, we can transform this equation. So in order to get a out of this equation, and we know all of the other variables here, we have to first multiply both sides by a, and then we have to divide them by sinus of b divided by b. So then what we get is a equals b with sinus of a divided by sinus of b, which in our case is b, 39 meters, and its sinus of a, which is 33.8 degrees, divided by sinus of 1.5 degrees. 828.8 point. Now, we have our a, so we can use the second equation to calculate h. In order to do that, we have to again transform this equation a little. If we divide both sides by 1 divided by a, then we will get that h equals sinus of c times a, which is in our case sinus of 35.3 degrees times 828.8 meters, and this 478.9, and that's our h, 478.9 meters. So we know how high the mountain is from the standpoint of my measurements. So now, in order to get the absolute altitude above the sea level, we have to just add this altitude here to this. And if we do that, the big H, let's call it a big H, is equal 1926.9 meters. So thanks to technology, of course, I could check how high this mountain or this place actually is from a map. And it appeared to be, as I written here, 1917 meters, which means I've almost got it. Of course, in real world, surveyors have much more precise devices than a smartphone. But even though I was able to get quite a good estimate of how high the mountain was. When Everest was measured for the first time, the same method was used. Easy, isn't it? Well, wrong. In real life, there are a couple more factors to be taken into account when using this method. First of all, there is the atmospheric pressure reflection. Secondly, then there is the curvature of the Earth. And finally, the gravitational force of the mountain itself. Now, let's go back to the mountains, because I have one more thing to show you. Even today, measuring the height of Mount Everest or any other high mountain is not an easy task. The results produced by pressure-based altimeters can be off by 15 meters or more. It's okay for the plains, but it's not okay when we try to measure the mountain. The best tool we currently have is GPS. However, even GPS cannot be relied on blindly in every situation. So maybe now you can see that it's 1400 something meters. Is this altitude correct? Well, it's a question that I already can say it's wrong, because I know that the Hutte that I can see there, the mountain shelter, it's on 1610 meters, because that's the altitude that was written on it. In order to get a reliable GPS reading from a GPS receiver, it has to be physically placed on the place that we want to measure and left it for a period of time, for example an hour. Then this device will collect the data and give us accurate measurements, which will be off by as little as maybe 10-15 centimeters at the moment. Now we know how to measure altitude. Therefore, let's be back to our original question. How do we measure altitude on Mars where there is no sea? How do we know that Olympus Mons, a dormant volcano on Mars, has 21,229 meters and meters above what? How do we know that Hellas Platinia has 7,152 meters below and below what?